Okay, so in this video we're going to look at conjugate acid and conjugate base pairs. We said an acid is something that can donate an H+, and a base is something that can accept an H+. And when that movement of H+ occurs, when the acid gives up an H+, or a base accepts an H+, because we have moved an H, we have changed what is an acid and what is a base. So a conjugate acid is formed after a base accepts an H+. So what was a base becomes a conjugate acid as it accepts that hydrogen. Well, that means that a conjugate base then is formed when your acid gives up or loses that H+. So what was an acid is no longer an acid because it's given up its H+. Now it's a conjugate base. Okay, so let's look at that in labeling. So we're going to label the acids and bases in the following, meaning label the acids and bases and label the conjugate acids and conjugate bases. Okay, so when you're looking at one of these equations, the easiest thing to do is actually look across the arrow first. Find the parts that match. So obviously the HCl and the Cl go together, and then that would leave the OH and the H2O to go together. Okay, so we're going to look at the H and the Cl just because I think it's easier to do so than to look at the OH and the H2O. What happened from here to here? On this side we have an HCl, and on this side we just have a Cl, which means that during this reaction the HCl must have given up its H if now over here it's Cl. Well, the only place it can give up its H2 is to what's on the same side of the arrow. So that means the HCl had to give up its H to the OH so that the HCl becomes Cl. And if the HCl gives up an H+ to the OH, now the OH is going to become H2O. Okay, so we see that the transfer has to occur from the HCl to the OH so that the HCl becomes Cl and that the OH becomes H2O. So it means if the HCl is giving up its H+, by our definition it's an acid, so I'm going to label it with an A. Okay. Our OH accepts the H+, so by our definition this is now a base. Okay. So now come over here. This is a reversible reaction. So that means just as HCl gave up its H to OH to become Cl, Cl has to go back to being HCl. So that means this reaction must go the other way. Well, if the OH accepted the H+, it can also give up the H+. So that means the H2O can give up an H back to the Cl so that the Cl can become the HCl again. If the HCl was the acid and then it loses an H+, it is no longer an acid. So on this side, it is the conjugate base, which should make sense because this is going to be the one that's accepting the H on the other side, and bases accept, so this is your conjugate base. The H2O came from the OH, which was the base, so when it gained that H+, it became the conjugate acid because it accepted that H+. Okay, and also now it's going to be giving up the H, so now it's a donor, so it's an acid. So acid, base, conjugate base, conjugate acid. Okay, so let's look at another one. In my next one I have NaO minus H2SO4 producing NaOH plus HSO4. So what happened from here to here? I've got NaO and I have NaOH. So from here to here, we got an H. We got an H from somewhere. Well, the only place it can get an H from is on the same side of the arrow. So that means that the H2SO4 had to give an H to the NaOH. So that means that my arrow is going to go in this direction with the H+. So if this is giving up the H, is this the acid or the base? Well, it's the acid because it gave up the H+. Means this is the base. So if this gave up an H+, it should be HSO4. And when we look over here, it is HSO4. Okay? So now, looking at the other side of the reaction, NaOH has to get rid of an H to go back to being NaO. Well, the only place it can get rid of it to is the HSO4, which needs it to become H2SO4 again. So the arrow's got to go this way. And now what was the base is now the conjugate acid, and what was the acid is now the conjugate base. Okay, so base, acid, acid, base. All right, we're going to look at our last one. Now this kind of is the trickiest one of them all because how can you tell what's going on here? They're exactly the same. So when you have this situation, you assume that the order is maintained so that this H2O corresponds to this H3O plus, and this H2O corresponds to this OH minus. Up here, I could switch the order around and you would still be able to tell what's going on because they're different things. But down here, that's not the case. So when they're the same, you assume the order is conserved. So these two go together, and again, these two go together. Okay. Well, I can't tell a darn thing by looking at this side because they're both the same. So I have to start over here. So what had to happen for this H3O and this OH to both become H2O and H2O? Well, the H3O is going to have to give up one of those H's to the OH. That's the only way this is going to occur. So I'm going to draw my arrow in this way. And here's my H moving. So if my H is moving on this side, is this my conjugate acid or my conjugate base? Well, it has to be my conjugate acid because it's the one that's giving up the H, which would make this one what? The conjugate base. It's accepting the H. Well, now come back over to this side. If I know that this H2O is going to become H3O, is this accepting or giving up an H? Well, if it's going to go from 2 to 3, it has to be accepting. And the only place it can accept it from is this one. So there's my arrow. So is this the acid or the base? Well, if it's accepting the H, it has to be the base. If this is giving up the H, it has to be the acid. Okay, so conjugate acid, conjugate bases.